Hello, in today's video, we are going to be looking at the number system, which is one of the building blocks of mathematics. And we are going to be looking at the natural numbers, the whole numbers, the integers, the rational numbers, and irrational numbers, real numbers, and complex numbers. The things we are going to be looking at are the symbols we use to represent each of them, the kind of numbers that are found in each of them, and the examples. I'm going to be making it as simple as possible to the layman. So the natural numbers, the symbol we use to represent the natural numbers is the capital N symbol. Write it like this. And the natural numbers, these are the counting numbers. They are counting numbers. So when you have a number of oranges in a basket, we use the natural numbers to count how many oranges are in the basket. And so examples of the natural numbers are 1, 2, 3, 4, and so on. So we notice that natural numbers don't have zero and they don't have negative part, even though some books may include zero in natural numbers. But what we call natural numbers are numbers we use to count. The next we look at are the whole numbers. There is no exact symbol we use for the whole number, but for reference, we are going to denote it with W. So the whole numbers, these they are numbers that include all the natural numbers plus zero. So example 0, 1, 2, 3, 4, and so on. So the whole numbers, as you can see, they include the natural numbers and zero. So as the name implies, they are whole. There are no fractions in them. The integers. The integers expand the whole numbers and include negative numbers. They expand on whole numbers by including negative numbers. Meanwhile, the symbol we use for integers is Z. This is the symbol for integers, Z. Examples of integers are minus negative number, -2, -1, 0, 1, 2, 3, and so on. So the integers comprises of whole numbers and negative natural numbers. So we have negative numbers from infinity to positive numbers to positive infinity. The next we'll look at is the rational numbers. These are numbers that can be written as a ratio of two integers. Again, the symbol for rational number is Q. Q is the symbol for rational numbers. They are numbers that can be written as a ratio of two integers. That is P over Q. As the word implies, ratio, they can be written as a ratio of two integers, P and Q, where P and Q are elements of integers and Q is not equal to 0. If Q is equal to 0, that means the number will be undefined, not be rational numbers again. So rational numbers are numbers that can be written as a ratio, as fraction in a layman language, as fraction of two integers. Example of rational numbers are 1 over 2, 3 over 5, terminating decimal 0.75, recurring decimal 0.33333, and so we represent it as 0.3 bar. Another recurring decimal 0.214214, and we represent it as 0.214 bar. This shows recurring decimal. Even negative fraction 1 over 5. These are examples of rational numbers. Even integers are part of rational numbers. 4 is a rational number because it can be written as 4 over 1. Minus 3 is a rational number because it can be written as 3 minus 3 over 1. So these are examples of rational numbers. The next is irrational numbers. The symbol is Q prime or Q complement. So numbers that cannot be written as a ratio of two integers are called irrational numbers. So these are numbers that you cannot write, that cannot be written as a ratio of two integers, e.g. pi. You'll be wondering, but in high school you are asked to take pi as 22 over 7. Yes, pi is not 22 over 7. The reason you are asked to take pi as 22 over 7 is so that it can be used to simplify problems like circumference of a circle and the likes. Pi is a non-recurring decimal. It is written as 3.141592653, and it continues. They use 22 over 7 as the closest approximation of what pi is. If you check 22 over 7 in your calculator, this will give you 3.142857 and so on. And so pi is an example of irrational numbers. We cannot write it as a ratio of two integers. This is not what pi is. I repeat, you are just giving this as an approximation of pi. This is this, and look at what pi is. And these two are not the same. This is 4159. This is 428. And so another example of irrational number is exponential. Exponential is given as 2.7182818 and so on. This is a non-recurring decimal. This decimal continues to infinity without repeating itself. And so it is classified under irrational numbers because we cannot put this number as a ratio of two integers, or we cannot put this number as fraction. Other examples are root 2. Root 2 is 1.414213 and so on. They are non-recurring decimal. We cannot put root 2 as a fraction. And other root 3, root 5, root 11, root 17, and so on. These are what we call irrational numbers because we cannot put them as a ratio of two integers. Of course, you can also find negative rational numbers like minus root 2, root 3 over 2 is also an irrational number because this is not a ratio of two integers. Minus root 11 over 5. These are all irrational numbers. The next we are going to look at is the real numbers. For the real numbers, these are those numbers that include both rational and irrational numbers. So the real numbers basically include rational numbers Q union irrational numbers Q prime. The symbol for the real number is R. That's the symbol for the real numbers, R. So examples of the real numbers are all possible numbers you can see on a number line. So if I draw a number line, all the possible numbers you can see along this line are real numbers. So you can find 0 there, you can find 1 over 2, you can find root 2, you can find exponential, you can find pi, you can find root 7, you can also find 8, you can find 20 over exponential. For the negative part, you can find even decimal numbers minus 0.5, minus 4 over 3, minus exponential, minus pi, and so on. Whatever you can list, you can find on the number line. These are what we call real numbers. The final number system is called the complex numbers. The symbol for this is C with a vertical line. These are numbers beyond the real numbers. They are numbers that are beyond the real number line. They include real and imaginary part. They are written as x plus iy such that x and y are coming from the real numbers. If and y is not 0, because if y is 0, it becomes a real number. And this I is given as square root of minus 1. Examples of complex numbers are 3 plus 2i minus 5i minus I, 4 minus 2i, pi I, exponential minus pi I, and what have you. Now, how do we find the inclusion or the embedding? The inclusion is also called, this is the embedding of all the number system. So the first one we look at was the natural numbers. It's a subset of the whole numbers, although the whole number doesn't have a symbol, but we just denote it with W for representation. The whole number is a subset of the integers. The integer is a subset of the rational numbers, denoted as Q. The rational number union the irrational number, they are subsets. The union are subset of the real number, and so the real number is a subset of the complex number. So this is what we call the inclusion. Natural number subset of the whole number subset of the integers subset of the rational number union, the irrational number is a subset of the real numbers, and the real number is a subset of the complex numbers. And so let me give a quick sketch on how these numbers are represented. If I start with the natural numbers, we know that the symbol is n, and they are 1, 2, 3. The next layer will be the whole numbers. This just adds 0 to the natural numbers. The next layer will be the integers. This just add the negative part, -3, -2, -1, and the rest. And the symbol for this is z. The symbol for whole number, even though there's no symbol, we use w to represent it. The next layer is the rational numbers. The rational numbers, the symbol is q, and so it includes the rationals 1 over 2 minus 3 over 4, 0.56 minus 0.7575, which will be represented as bar. So these are the rational numbers minus 4 over 7. The next will be the irrational numbers. Let us include it here. Irrational numbers. And the symbol is q complement. So they include pi, exponential, root 2, root 3, root 7, and the rest. And the next will be the real numbers. Remember, the symbol is arrow, and they include all the numbers you can find on the number line. They include the rationals and the irrational. And finally are the complex numbers. They are complex numbers with symbol C with a vertical line. They are numbers in the form of x plus iy, such that x and y are from real numbers and y is not equal to 0. And so examples are I, 3i, minus 5i, 2 plus 3i, 3 minus I, 4 plus 2i, and the rest. Thank you for watching. If you are yet to subscribe, make sure you subscribe, follow, like this video, and share to others. See you in the next video. Bye.